Hello, my name is Alan Bao, ALAINBAO, and I graduate in statistics and computer science. So in this channel, I will try to show statistics and calculus, algebra, calculus. Yeah. Probably or one day I will show statistics, and the other day I will show calculus. Besides, I will share some of my hobby, my collection sporting car, or Pokemon, for fun, and some music lesson. And also I have an eBay store where you can buy or support me by stop by my eBay store to buy things. Okay, I will give my eBay store address in the description of the YouTube channel. Okay, so to begin, I'm good. Today I will start with calculus first. Hello, today we will learn inequality and how to show inequality expression. Okay, inequality, that means not equal. So everything is not equal, it's called inequality. So let's say you have 7 greater than 3, a greater than 1, 0 greater than -1, -1 less than -2, 0 equal 0, 3 equal 3, and etc. Okay, so but this lesson I will show you how to show inequality just by one method for every inequality. Okay, so the first one, let's example, we have x plus 3 minus plus equal 2. No, sorry. X plus 3 greater than 2. Okay, so this one inequality, but since it have one variable, so you have this one called one variable inequality. Okay, so we need to find the value of x such that x plus 3 greater than 2. Okay, so with equal, you only usually have like single value, like 1 or 2 value, one value. But with inequality, you have a region of x, like several x. The solution should be several x to satisfy the inequality. So to show this x plus 3 greater than 2, the first thing you have to do is move everything to one side, and that one side equal 0. So here 2 here. So you can move to the left. So -2 both sides. So 2 will go here. So x plus 3 minus 2 greater than 0. So x plus 3 minus 2 is x plus 1 greater than 0. So from this inequality expression, you reduce to this expression right here. One side 0 and one side expression. Okay, so from that you need to find x-intercept of this expression. Okay, so when x-intercept, that means y equal 0. Okay, so suppose I have, let me give you some explain this. So suppose you have this line, draw that line here, x plus 1. Okay, so here is the coordinates x and y. So here the line cross intercept x. This point here called x-intercept, and this point A have the coordinate of change it on x, so it from here to here is let's say, I don't know, let's say x value, and it have y it have the y value equal 0. So when x intercept y equal 0, from here to here, this line, the graph cut on y, we call y intercept. So the graph intercept with y, then we go down, we have x equal 0 and y value. So that we call x intercept and y intercept. So just when you remember x intercept, that means y equal 0. Just use the other value. So that means y equal 0. So put y equal 0 here. So when y equal 0, that means the whole expression here equal 0. So x plus 1 equal 0, right? So when x plus 1 equal 0, then minus 1 both sides, and x equal negative 1. So this point right here, x intercept have the coordinate, let's say A, x equal negative 1 and y equal 0. So this point x intercept, okay, and you have y intercept. Y intercept, that means this point right here, the graph cut to the y, so therefore the value of y equal 0. The value of x equal 0. Y intercept, that means x equal 0. So you have x equal 0, and in order to find y, you have to substitute to this equation. So x equal 0 y, x equal 0, 0. So you have, okay, y equal x plus 1, right? So x equal 0, when x equal 0, then 0 plus 1 equal y. Then y equal 1. So we have the y intercept point is x equal 0, alright, x equal 0, y equal 1. So we have 2 points here. Okay, now the third one, you need to draw the table. Okay, just the table. So you only have one expression. So from here, okay, the first column right here is x value. So from here to here, x start from negative infinity to plus infinity. Okay, and the second is y. Y now equal this one right here. You only have one expression. Y equal x plus 1. Okay, so we need to find all the value of x such that x plus 1 greater than 0. So that's why we always have x right here, but we need to find x plus 1. So we have this here. Okay, so the value of x always, x right here, the domain of x, the value of x run from negative infinity to plus infinity. So in this value right here, we need to find the value of x such that the whole x plus 1 greater than 0. Okay, so in order to do that, you plug it in right here, x intercept and y intercept. So when x, so you have x equal negative 1 right here. The first point, when x equal negative 1, y equal 0. That x intercept, and then when x equal 0, y equal 1. Okay, x equal negative 1 less than 0, so you have to put behind. So the order is really important. So when you find x intercept, right here, negative 1, 0, and y intercept 0, 1, you see that negative 1 less than 0, then you have to put behind 0. Negative 1 first, then 0, and then when x equal negative 1, y equal 0, and y equal 0, when x equal 0, y equal 1. Okay, now we have to see the sign of this. Okay, so from here to here, okay, from here to here, so x, so from here to here, so y equal 0 here, and then 1 and star up to 3. So from here to here, from 0 to 1, y is positive, this trend right here, and from here to here, y equal negative, right? Okay, from 0 to back here, negative infinity, y negative sign, because it's less than 0. Okay, the value right here is y equal negative 1, negative 2, negative infinity, and from here to here, from 1 to infinity. So, and then now we go back to that one. We need to have x plus 1 greater than 0. That means y equal x plus 1 greater than 0. That means right here, greater than 0. So it must start from here. Okay, so from here, so y equal y from here, so y equal x plus 1 greater than 0. And that's the expression we need to find the value of x right here. So in order to qualify that, so x must be from negative 1 to infinity. So from this value right here, so x will be from negative 1 to 0, and then from 0 to infinity. But so that means x greater than negative 1. Okay? Or you can write an interval notation, like x will belong to starting point with open bracket, negative 1 to plus infinity. Okay, so either you write this or you write this. So that's the general method to show inequality. Okay, and if you usually this is simple, so you only have to do just like that. If you don't know this one, but this one is general to show as many expression here in inequality. So if this one so simple, we don't have to go over this. If you don't want to see, you can see x plus 3 less than 2. Then to show it, you just minus 2 both sides. Then you have x plus 1 greater than 0. Okay, and then to show x here, just isolate x, you get x, and then you negative 1 both sides. Subtract 1 both sides, and you have x plus 1. You get the answer right away. But that only you can do that with the simple expression, the first equation, first expression. Like that you can do directly. But if they have like that, just square root 3 root 2 divided by root 3x divided by x plus 1 times x plus 2 greater than 0. You cannot do that. You cannot isolate x by themselves, because right here you have power of 2, sometimes power of 3. You cannot do that. Okay. Okay, so we study the symbol, only one expression already, right? So now, suppose we have two expressions. So you have x plus 3 over x minus 2 less than 0. Okay, so this one you do the same thing. Okay, so this time we have two, right? Two expressions right here. So you have to find two of them. Okay, so first of all, we need to find the x-intercept. Okay, so here y will be equal the whole thing. Let's take y equal x plus 3 x minus 2. Okay, let y equal that, the whole thing less than 0. So when you write, it's easier. Okay, so now you have so you will find x-intercept. So when so you have okay, y. Okay, so first you have find x-intercept. X-intercept when y equal 0. Okay, so y equal 0. Then x plus 3, x minus 2. Okay, that's one equal 0. Don't equal 0. So this one, the quotient. So you have x plus 3 over x minus 2 equal 0. So that means the top equal 0. The top, okay. So that means x plus 3 equal 0. So x minus 3 both sides, x equal 3, x equal minus 3. So when x-intercept y equal 0, then you have the first point, x equal minus 3 and y equal 0. Okay, and y-intercept, y-intercept, that means x equal 0. Okay, you have y equal x plus 3, x minus 2 equal, put x, replace x equal 0 in here, you have 0 plus 3, 0 minus 3, minus 2 equal 3 minus 3 and a half. So when x, you have the B point, x equal 0, y equal negative 3 over 2. Okay. So now we draw the table. Okay, now we have x right here. Remember x right here? And since we have two expressions, we have x plus 3 on the top right here, and then the other expression x minus 2. Okay, and the last one is y. Y is equal the whole thing, x plus 3 divided by x plus 3 divided by x minus 2. Okay, so x will vary from negative infinity to positive infinity. Okay, first we need to find domain of x, but right here since x plus 3 over x minus 2, so right here because it's a quotient, so denominator x minus 2 cannot equal 0 because anything divided by 0 is undefined. Let's say 2 divided by 0 is undefined. 10 divided by 0 is undefined. Like you have 10 cookie, you give to no one. Doesn't mean anything yet. That means you don't give anything yet. 2 divided 0. Okay. So here, so x equal 2, y is undefined. Okay, undefined. You can use the 2 line parallel down to make the notation. Okay, so replace when x equal 2, so this top right here, this quotient here, 2 plus, when x equal 2, this one equal x minus 2 equal 0. Okay. Okay, now we plug in x-intercept and y-intercept. When x-intercept and y equal 0, so here we have x equal negative 3, y equal 0. Okay. When x equal 2 equal 5, 0, and then undefined. Okay, and this one, when x equal negative 3, and here equal 0, plug in here, equal 0, negative 3 plus 3 equal 0, and this one negative 4. The second expression is negative 4, but then when you plug in the whole thing, y equal x plus 3 divided by x negative 3 minus 3. So plug in here, you have minus 3 plus 3 is 0, and minus 3 minus 2 is minus 5. So we have minus 5 in denominator, and then 0 for 0 divided by minus 5, 0. So we have 0, okay? Okay, so from here, we want y less than 0. Okay, so from here to here, you can see y less than 0, and from here to here, y greater than 0. From here to here, y less than 0. From here to up to here, infinity, y greater than 0. But we want y less than 0. So if we start from here, that means y as x must be less than negative 3 right here from here. So from that point, from this area, region right here, just y equal x plus 3 divided by x minus 2 less than 0, then x must be from here. The whole region is from negative infinity. So x must be from negative infinity to 3 to negative 3. That's the solution. Or you can write that, I can just add less than negative 3. So that's the solution, the whole thing. So I guess I stop here. So next time I will review again. It looks complicated, but actually it's really simple. Just keep doing it. Okay? Alright, so I see you in next video.